Right, so Year 12s, we've done integration before. We did integrations when we did that. The last exercise in Chapter 2 with primitive functions. So these are actually just the common rules to integrating. Before we integrate, you need to know sort of symbols. So that symbol here, that's the symbol for integration. So that's the integration symbol. So integrations is the opposite of differentiation. So when you want to reverse any differentiation, you integrate. So that's fx is just your function, and that dx actually stands for with respect to x.
I don't see how you got that.
How both of these symbols are the same?
Well, dx actually comes from delta x, so that's probably, it's just a continuation of that. So you would read this as integrate fx with respect to x. If I changed it, say I have this one, ft dt, you'd read that as integrate the function of t with respect to t. So basically, all that tells us to do is we're only integrating the x part of the function. So we don't do anything too complex in 2-unit and 3-unit that has multiple variables, but in 4-unit, yes, 4-unit, you guys have to deal with 2 variables at the same time. So that's why you actually need to know what you're integrating. Okay, so the common rules are if you have a constant term, you just add an x to the end and you plus c. So that's a constant. If you have an x to the power of n function, you pretty much increase the power of the function by 1, so that's the opposite of differentiating, and then divide by the new power, and you plus the constant term. So now, this part here, you've done something similar to this, but this is the official rule for it. So if you have a times x to the power of n, basically a is a constant, and we can take our constant outside. So what we've done here is we've taken our constant outside our integration. We've integrated, so I've just integrated that part, and then I times our integration with a, and that's your final solution there. And the last one is function of the function rule. So when you were doing exercises in 211 it was, I think, or 210, depends on the textbook. Remember how I told you to expand it and integrate it? Now, you don't actually have to expand it and integrate it. There's actually a set rule for it. So we'll do some examples with each individual parts. And that should set you up for doing that exercise. I think it's 3, 4. Okay, examples. So some examples. We'll go with the hardest one. We'll do the function of the function rule first. To the power of 5 dx. So according to the function of the function rule, I have everything inside the brackets. So you keep everything inside the brackets. You increase the power by 1. Then you divide by the coefficient in front of x. So 8 is the coefficient in front of x. So looking at that question, what's the coefficient in front of x? That question. What is it? Well, for this one, it's A. For this one here, what's A represent? So A is 1 times the new power, which is 6. Okay, so I'm just going to clean this up. So it's x plus 4 to the power of 6 over 6 plus c. Okay, so not too difficult. What about if I have something like to the power of a half? No? Get rid of the power of half, change it to a radical symbol. So don't forget when you're integrating, you have to put the dx at the end. Right, so if you have this question here, you change it to your index law. So the index law for this is 5x plus 7 to the power of a half. And don't forget your dx. So how would we integrate this? What do we do with the What do we do with the brackets? now we need to multiply by the coefficient of x, which is 5, and we times it by 3 on 2. So this is going to give you the plus the plus 2, 3 on 2, and that's 15 on 2. How do we change this into a single fraction? Do you know? Sorry. Do you know what this is as a single fraction? 2. Yeah. 2 outside, 5x plus 7 to the power of 3 on 2, all over 15. Do we need practice with like rule 3?
Yes.
A bit of that.
Using example 1 makes you over 7.
No. Why is it over 7?
Because the rule said you have a outside of n plus 1.
Well, I think that's times.
Yeah, but a outside of n plus 1.
And
So-
5.
Oh,
That's
okay,
right.
sorry.
Sorry, yeah, I should have done that as I should have just kept it as brackets 5 plus 1. So what was it, skipping steps? Alright, how about I combine something like an integration that has rule 3 and 4 together? 7 brackets. This is really hard to think of. 7x minus 1 to the power of negative 8 dx. So this 7 in front is a constant, so what we can do is we can take the 7 outside, take it outside, and that gives you 7 times the integration of 7x minus 1 to the power of negative 8 dx. So we'll leave the 7, we'll multiply 7 later, and we'll integrate first. So we'll leave the 7 there, and we'll just integrate this. No one wants to volunteer their answer? No? Okay. No one? This is so awkward. Okay. So keep the brackets, keep everything inside the brackets. Increase the power by 1. So what's what? Minus 7. Divide by, so this, divide by the u power times what?
The coefficient.
Yeah, so divide by the coefficient in front of x, which is 7, times by the u power, which is negative 7. And remember, we still have that times 7 on the other side. So if I actually just simplify, I can cancel both 7's out. And what I have left is negative 7x minus 1 to the power of negative 7 all over 7 plus c. And if we want to make this as a fraction and not as a negative index, it's just going to be negative 1 all over 7 bracket 7x minus 7 to the power of 7. So all I've done from here to here is just convert it into fractional form. So exercise 3.4 is very similar to what we've done in when we first started integrating.